What is up, my mammals? Okay, so today we're going to jump straight into molecules of life. Okay, and I'm going to give you a quick overview. That's all this video is. It's the overview, it's the big ideas, the big pictures that we're going to be looking at specifically for the different classes of these biological molecules. Okay, so the four classes that we're going to learn about are carbohydrates, lipids, proteins, and nucleic acids. You've probably heard these before. If you have ever looked at a food label, you've probably seen a couple of these. If you've thought about what you're eating, you probably have seen most of these. And then if you have any remembrance of previous life science classes, you've probably seen these before. Okay, so not super new to you. But we are going to look at these as classes of macromolecules. Okay, so let's talk about some vocabulary. Okay, in biology, if you don't know what it is, rely on the roots of the words, the suffixes of the words, the prefixes of the words, and we can start to kind of develop an idea of what it is without actually knowing. So let's look at macro. Okay, macro means big, right? As opposed to micro, which means small. Okay, and then we've got molecules. So if I've got macromolecules, I'm looking at big molecules, okay? And here's how we get those big molecules. What we're actually going to do is we're going to take those molecules, singular molecules called monomers, and we're going to put them together to make a larger molecule, which will be our polymer or our macromolecule. Okay, so I'll give you a visual to kind of recognize what this means. Okay. If you picture Legos, okay, little cubey thingies, okay? If I have just one of these Legos, this is considered a monomer, okay? If I take multiple of these and I put them together, now that's a polymer, okay? And now I've got more of them, okay? So there are monomers that make polymers, okay, in all four of these classes. We've got individual monomer carbohydrates that bond and make polymer carbohydrates. And then we have those for proteins and nucleic acids, and then there's components of lipids that are kind of weird and funky. But all classes of macromolecules have their own monomers that can form and make polymers. I'll give you an even crazier example. Okay, in proteins, for instance, I have multiple types of monomers, okay, all these different varieties of monomers, and they can go together in really crazy different orders, okay, in different colors and make these bonds, and all of these will be able to perform a different function, okay? So one of the things that we like to talk about when we're talking about macromolecules is how whatever structure we're building, whatever way we put our monomers together to make polymers, will create a new specific function that is not the same as if we were to construct them in a different way. Okay, so this is something that's going to span all the way across biology. Is this form or this structure will fit a function that is specific to the way that that looks. Okay, so let's keep rolling. Now that we know we are putting things together, and we're going to do that for everything, let's talk about the actual process of putting things together, okay? So there are two processes that we need to know when we are talking about our macromolecules. We need to build macromolecules, we need to put monomers together, and then we also sometimes will need to disassemble those polymers, okay, and make individual monomers, all right? Because if we don't like the way that these go together, we might need to move them around and rejoin them to make a different function. So that's the bell, okay? But we have the first reaction called a condensation reaction or a dehydration reaction, okay? You'll see this as dehydration synthesis sometimes. So break the word apart. Dehydration, we're probably losing water, and then synthesis or condensation, we're actually joining things together. Okay, so that's kind of crazy to think that we're going to lose water, but we're going to put things together. So what happens is we're going to take out a water molecule, and it actually puts two monomers together to give us a polymer. Okay, the opposite of that is when we have a polymer and we need to break it down, we're going to go through the process of hydrolysis, okay? So hydro, we're talking about water, so we're going to add water. And what that's going to do is it's going to lyse, okay, or break things apart, okay? So let's talk about like that vocabulary just for a second. We're going to see lyse or lysis a lot, okay? We'll see glycolysis later in another unit. Glycolysis, lysis, we're breaking glycogen, okay, or glucose, okay? So we can use those words when we get stuck to break things down. So, you might be on a test and you see lysis as a suffix. Well, in your head, start thinking, okay, we're probably breaking something down. So that's just one example of, again, how our vocabulary is going to build on itself, and we're going to see these words over and over again. So having a good understanding of what they mean now definitely helps us in the long run, okay? So one more time, just to summarize this slide, we have dehydration synthesis, dehydration reaction. We take out water, but that builds us a polymer, okay? We also have hydrolysis. We add water to the equation, but that's going to break us apart so that we have two individual monomers, or we break those bonds for whatever there is, okay? So here's what that looks like. Here on my slide, you can see we have individual monomers, 1, 2, 3, and then there's a fourth one here. During the dehydration reaction, what we're doing is we're taking out H2O. We got an H from this side and the OH from this side, and we're going to pull those out, and we've lost water, but we formed a bond to make an even larger polymer. Same thing reversed, okay? Hydrolysis is where we add water to the equation, and what that does is it's actually going to break that bond so that now we have an individual monomer from this polymer, okay? So those two reactions are going to be super critical for us moving forward. We got to make sure we know them. We have to understand how bonds break and bonds form with the addition or the subtraction of water, okay? You guys are awesome. Hope you're having a great day, and I will see you later.